So for your warm-up, the first thing I asked you is how do you find the zeros of a rational function? How do you find the zeros? You can tell me that part. What do you do? Yeah, Ava?
Find the LCD and solve.
So the zeros is where you set the numerator equal to 0 and solve. So the zeros are going to be with the numerator, and then to find the vertical asymptotes, that's when you can use the LCD, because that's when you're going to use the denominator. And when you're finding the zeros, that's the same thing as finding what? What's a zero? Where is the 0 on the graph? Yeah, those are the x-intercepts, okay? And then for 2, I said, how do you find the vertical asymptote? So that's when you set the denominator equal to 0. And then the horizontal asymptotes, there's some special rules for those, okay? So, I love this. I'll show you what I did for those. Okay, so to find the zeros, you have to set the numerator equal to 0 and solve. Okay? It's okay if you didn't. If you did shorthand, that's fine. I wrote some notes on that, that's fine. But I want to go over these rules together. So for the vertical, that's when you can set the denominator equal to 0 and solve. And for the horizontal asymptotes, the main thing I want to make sure you understand is that you are comparing the numerator degree to the degree of the denominator. Okay, so if you had to explain this, make sure that you emphasize it is the degree. Don't just say it's the numerator and the denominator, okay? So if there's an explanation part, you are going to have to make sure that you mention the degree in there. Okay, and then do remember the rule, if the degree of the numerator is greater than the denominator, what does that mean about the horizontal asymptote? Yes, there is none. Okay, and then if the numerator is less than, what's the horizontal asymptote? Y equals 0. So don't just put 0, make sure you put y equals 0, because asymptotes are lines, so we have to have that equation. And then the last one is if they're equal, what do we use? Yeah, the leading, yeah, good. So it'll be y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. Okay, and when you divide, if it simplifies, that is fine. Okay. Another thing that we talked about in terms of the asymptotes, which I am going to just show you on your 5.4 notes. Okay, when you're studying, I do recommend that you look back over your notes. And if you didn't do your homework and you noticed the first page was kind of tough for you to remember, go back and try some of those practice problems. So in the first part of the 5.4, we talked about the transformations, and then we also talked about the vertical asymptote here was x equals h, and the horizontal asymptote was at y equals k. Okay, so I'm just going to put a note that if it's in this form, if you have the f of x equals a over x minus h, plus k, that you can use that the vertical asymptote is x equals h, and the horizontal asymptote is going to be y equals k, because that's what's going to help us on the review, and that's going to help us when we graph for number 3, okay? So this is a special form, like where you have that added to the side. And then, of course, those are related to the domain and range, which we will go over that today as well. Okay, so then for number 3, and I am going to graph this on graph paper, but for number 3, you had to describe the transformations. from 1 over x. What is 1 over x? 1 over x is called the what? Yeah, the parent function, okay? So if you have f of x equals 3 over x plus 6 minus 1, okay, when you're talking about the transformations, notice if this is not a 1 on top, it's going to be a what? What does that 3 represent? Good. Okay, so I'm going to write out the transformations. Okay, so we have a vertical stretch by a factor of 3. Great. Okay, what's another one? Yeah. Good. Horizontal translation. Left 6 units. And then Yetta, do you know the last one?
Vertical translation.
Mm-hmm.
By 1 down.
Good. Vertical translation, 1 unit down. All right, great. Questions for me about that part? Transformations are fine? Again, if you need like a quick review on that, this little chart that we have in our notes, that's really helpful, okay? Now when we go to graph, there's a couple different ways that we can do that, and I am going to talk about the parent function when we go over our review. You can also use your graphing calculator. One thing I use to help me when I'm doing this is I like to make sure that I take into account what my asymptotes are. Okay. Another way that you can use that is you can use your graphing calculator, and when you are graphing, you should be able to see those in there as well. Okay, so we are going to graph. All right, so when you are graphing this part, you have to do the 3 divided by x plus 6 in your parentheses. Oh shoot, sorry. You have to do double parentheses. So you have to do 3 divided by the x plus 6. Close the parentheses and then do your minus 1. Okay, so remember that when we've always had the denominator and numerator, I've been reminding you to do the parentheses there. Okay, and then this one has that minus 1 on the outside. The only way, and that's why you have to have the other set. You could also make that one term, but you'd have to multiply by the LCD. And then let's look at our graph. Okay, so we can see the 2 branches there. I'm also going to look at my table. And when you're looking at your table, where would you expect to have an error based on where your vertical asymptote should be? Yes. Let's see. Yay, we did it. So -6 is your error. Okay? So the vertical asymptote for this would be if I took x plus 6 and set it equal to 0. So it would be x equals -6. Okay, and then your horizontal asymptote should be where? Based on this. You have the plus k? Yeah? Good. So it's y equals -1. Okay, so when I'm graphing this, one of the first things I like to do is put the asymptotes on there. Now I noticed when checking some of your reviews that some of you forgot to do the graph for your graphing problems, which does concern me because that's what your quiz is on the first page. So if you forgot to do your graphs on your review, it's really important that you do the practice. So I see some of you haven't graphed this one yet. Okay, so we can graph this one together if you haven't done it yet, but you're going to have to do some practice on your own if we're going to do it right next week, okay? All right, so looking at my points that I have here, looking at my values, if I went negative 10 to 10, doesn't look like I have like a very tall graph there. Okay, yeah, so it looks like 2 is the highest one I need. So 1, 2, 3, 4, 5, 6, 7, 8. Go out to negative 8. And I really won't need to go as far out on my x. Okay? So what I'm doing is I'm using this to help me. Now, you don't have to do it this way. I'm going to show you another way to do this when we go over your review. Yeah, Ava?
Would you recommend that we put this in the calculator or solve it, like just by multiplying the x values by whatever number?
It honestly depends on the student. So I had some students who were really confused about the parent function transformations last week. And so for them, I would absolutely recommend checking it with the calculator. Another thing, though, to be careful of when you're just using the calculator is those parentheses. So I do recommend finding these by hand and to use that to double check your work in there. So really a combination of both would be preferred, just to make sure that you didn't make any mistakes there.
Oh yeah, I didn't really make sense.
Well, and this one had several transformations. So see how you have the vertical stretch but also a vertical transformation? That means with the y coordinates you had to multiply by 3 and then subtract 1. So having the 2 things applied to the y, that can get a little bit confusing, which is why I think the calculator is helpful with that. And once you have these, you know where your hyperbola is going to go. Once you have those, then it's pretty simple to follow your table. And I think a lot of people are comfortable with the table. So at negative 8, we have negative 2 and a half. And then at negative 7, we have negative 4. And then you have your error here. At negative 9, you're at 2. So I'm going to use these points to help me create my curve.
So that's the inverse of the other one, right? Or is that the parent function?
This is your transformation. So this is your g of x. So I'm not going to graph the parent function for this one. But on your review, it was already graphed for you. So that one we are going to talk about how to transform it from the parent function. And this would be 2 at negative 5. At negative 4, I'm at a half. At negative 3. Sorry, you see what I did? I just moved these over. This one should go here, this one should go here. And now, these are going to get closer and closer to what number? Yeah, well not 0, but the asymptote, which in this case is? Yes. Okay, so as those get closer and closer, This one is going to follow those asymptotes there. Okay, so these I plotted one over. And then you have each branch from there. Okay, and now we're going to look at the first page of our review, which the very first question is very similar to this. I'm going to show you another strategy for how to graph with this type of rational function.